Requesting connection. Established. Encrypted. We're live. The show you've been asking for. Advice, technology, and community. Linux first, all others second. This is Ask Noah.
Live from Altispeed Technologies, the Ask Noah show starts right now. This is the show where we came to do all the things on Linux they said couldn't be done and take your questions on how to do the same. The phone lines are open this hour. To be a part of the program, it is a free call, 1-855-450-NOAH. It's 1-855-450-6624, or send an email to live@asknoahshow.com. My name is Noah Chalaya. I am your host, delighted to be here with you as another episode of the Ask Noah Show kicks off this hour. 3 Red Hat engineers have submitted a change proposal for Fedora Linux 41. If approved, this change would add optional support for native hardware encryption on TCG Opal 2 compliant drives within Fedora's Anaconda installer. So this is the new proposed way of supporting what's known as self-encrypting drives. And it's going to be landing in Fedora Linux 41. Now, it's only going to affect new installations, so if this makes you nervous, it's optional. You don't have to do it, but it's really, really cool. And here's effectively how it works. So this is based on something called Opal drives, and Opal drives have the ability to create multiple independent regions of individual encryption keys. So as with a traditional Lux system where the file system itself is encrypted, so the operating system creates a file system across a physical drive, it's typically encrypted with a single key. In an Opal drive, the encryption is actually happening at the hardware level, and different parts of the drive, different sections of the drive, each have their own encryption keys. And so they're able to read and write content. Now, this originally dates back, as far as I can tell, to the 90s, when engineers at Seagate and IBM were trying to find a way that they could build encryption into systems that wouldn't be easily exploited, because what was happening was they would do software-based encryption or file system-based encryption, and the government would go to dispose of drives, and then all of a sudden they'd have these drives floating around with sensitive data. And so they're trying to figure out a way that with no input of the user, you could encrypt a drive. And so the way it works underneath the hood, the drive has a default privileged user password, administrator password, and that is used to derive the key. The key is then used to encrypt and decrypt the drive. And so there's an actual data blob that contained the data containing the encryption key. The drive knew its default administrator password, and so therefore when it arrived straight from the factory, all the user had to do was pull it out of the box, plug it into their computer, and start using it, and it could easily determine its own internal key and begin encrypting all of the data going forward and then decrypting all of the data coming out without having to ask for anything from the user. So the end user then, if they chose to, could change the data blob with the output of a random number generator or with his or her own password, or the password printed on the drive itself, and that would then return the drive to a vanilla state and inherently leave the data on the drive irrecoverably encrypted. So the advantages of doing this are huge. So the first things first, it's great that it's being done at a hardware level because it means that there's less input necessary from the user. Secondly, performance is going to be improved on low power systems, because in a software-based encryption, if you're using Veracrypt or you're using KDE Vaults or you're using Lux even, when the file system is having to do that, you're relying on the system's processes. It has to go through the kernel, it has to go through memory, it has to go, and all of those resources must be consumed in order to encrypt or decrypt the system. When you go to a hardware level, even on a low power system, you're still able to use encryption. There's increased security through layered encryption. So you will now have the option when installing Fedora to say, I want to use hardware encryption only, I want to use software encryption only, or, hey boss, give me the best of both worlds. I'll do hardware and software encryption only. So the Fedora Engineering Steering Committee is the next stop. They're going to review this proposal. If approved, it could bring encryption options to Fedora Linux 41, potentially increasing the security and performance for users with compatible hardware. I want to emphasize this is optional. You don't have to do this, and the feature will be available only through the Kickstart interface. It's not going to be enabled by default, and users must explicitly select the option to use hardware encryption. But an extremely cool move, and once again, reminiscent of the fact that if you want to be on kind of the leading edge of stuff and you want to play with hardware, not just hardware, you want to play with technology in general, using Linux is a great way to do that. Using Fedora specifically is a good way to do that. When I was researching this a little bit, and I was like, I want to learn a little bit more about this, I was shocked to find out that this dates back to the 90s. The problem is proprietary systems aren't taking advantage of it. They don't want to, even though the physical hardware supports it, software manufacturers don't want to extend those features to their users. And so there's either no support at all or very limited support. So very cool to see this happening. Fedora Linux leading the way, and open source taking a front row seat to innovation.
From the Linux Newswire newsroom, this is the Week in Review with JT.
For the week of July 14th, 2024, here's the Linux and open source news. The photo management tool Digicam has released version 8.4. PeerTube 6.2 is out. The Arch package manager Pacman has just had its 7.0 release. Karoshi, a free and open source school server operating system developed by the Linux Schools Project and based on Ubuntu, has just released version 15.0. Calibre 7.14 is out. Snort 3.3 has been released. Nano 8.1 is out. EasyOS 6.1 has been released. Mozilla Firefox 128 is now available. GNOME 46.3 is out, as is KDE Frameworks 6.4. And the Linux 6.10 kernel has finally been released. In security news, CISA is offering tools to promote the secure use of open source software.
Dan Noal. He is the Director of Product Management for Red Hat in-vehicle OS and a guest this hour on the Ask Noah Show. Dan, welcome into the program.
Great to be here.
Thanks for making the time. So I guess let's start here. Cars, for a long time, have been these mechanical devices, and over time, they've become more electronic, and there's been more involvement of computers. Why does my car need an operating system?
You know, it's funny. I think that the days that we don't need an operating system are long past. We've had operating systems, even complex operating system in cars for decades. And what we've seen is a very complex, difficult to maintain kind of array of solutions that correspond to individual, we'll call them electronic control units or ECUs, that historically represent one vehicle function. And many of those individual ECUs are complex enough that a complex OS is necessary to handle OS services, that just writing bare metal code is just going to be too complex, too hard to maintain. So we need complex OSs. That's decades old. But now that the architecture is being disrupted by things like electrification, things like autonomous driving, and the whole paradigm that we'll talk about today of the software-defined vehicle, the demands of the OS are even more complex. And the need to consolidate ECUs, the compute power is there. We need to consolidate ECUs simply because there's not enough space. So if you can get that, right, we're going to run out of space if we segregate one box per vehicle function. Too many wires, too much complexity. The interconnects between these boxes gets too complex. So it actually becomes simpler to consolidate. But that simplicity has got to be underpinned by the foundation of a complex OS. And that's where we think Red Hat has an opportunity.
Can you talk to me about how Red Hat plans to address this? So if you had all of these individual systems, these different domain things, something is handling the drivetrain and the braking, and another thing's handling infotainment, but they're all separate things, all doing their own things. Maybe they're made by different manufacturers. How does bringing everything together, in addition to saving space, how does it make things more efficient, and is there a safety and security aspect to it?
Great questions. So really the impetus behind this change is with the OEMs and managing complexity, managing their supply chain. So as you correctly point out, you've got different OSs, different application stacks provided by different suppliers. And when I need to have these systems intercommunicate, network together, have APIs that flow back and forth, as I'm going to need to bring higher value features to consumers. And I can give you some examples of that. The OEMs themselves are driving the change to consolidation, to simplicity, to less operating systems from their suppliers. They're mandating which silicon, which operating systems, what the architecture looks like. They're not leaving their architectural definition in the hands of their supply chain. They're taking more control themselves. And then, you asked several questions there. You asked, doesn't this present new cybersecurity risks? I think fundamentally the cybersecurity risks were already there. And the OEMs were seeing that entrusting the cybersecurity wellness of the overall architecture to pieces developed separately without communication was actually an increased risk. They had to manage that risk through consolidation.
So how does Red Hat address those things? Talk to me about Red Hat's solution for these problems.
Okay. So Red Hat's heritage, of course, is in enterprise computing. And interestingly enough, in-car compute architectures are getting closer, not all the way there, but closer to what Red Hat is known for with enterprise workloads. Consolidating workloads, that's Red Hat's strength in the enterprise. Managing multiple workloads simultaneously that, if they interfered with each other, could create harm, central to what Red Hat does in the enterprise. We're trying to bring what Red Hat does best in the enterprise to the in-vehicle use case. There are architectural differences, so we have to be aware of that, accommodate that with some unique content for automotive. But the vast majority of what we're doing is derived from Red Hat Enterprise Linux.
Talk to me about a real-time operating system. So obviously in the enterprise, as bad as it is for a company for their server to go down, at the end of the day, unless you're talking about healthcare, probably nobody is dying. It's a bad day and probably people are losing money. When it comes to a vehicle, if you step on the brakes and the command or the thing crashes, that could be a real safety concern. How do you address those issues, or how do you design a system with the necessary infrastructure or redundancy and safeguards in place so that you can rely on it in a mission critical situation where the computing power has to work basically 100% of the time?
Well, this is really a good question. And you make a good point that in the data center, we have very important things going on. And when they go down, that's important and that's a problem. But it doesn't result in the risk of death. So when the risk of death is involved, the entire industry and multiple industries, not just automotive, but medical, industrial use cases, avionics, and airframers, they've established functional safety standards. And Linux, as an open source, community-driven project, has been historically disadvantaged and, to some thinking, not eligible or just too difficult to get through the functional safety certification process. Red Hat, with our partner Exida, has developed a new and innovative approach to bring the strengths of Linux and basically adapt our argumentation to fit through tailoring the functional safety standards. And that's really the key thing the industry has been looking for. There have been multiple aborted attempts in our industry to bring functional safety and a solution based on Linux to functional safety. And Red Hat believes we have, with our partner Exida, developed a unique approach that's going to make that happen. And that's really the crux of our initiative. If we can do that, then all of a sudden Linux, which is running today in automotive for what we call non-safety workloads, like infotainment that you point out, maybe the communication or gateway module that allows a phone to connect with the cloud, etc., would be not safety critical. But that's the minority of the automotive workloads. Many of the automotive workloads would like to convert to a Linux-based architecture and what we're bringing, but have been blocked from doing that because of this functional safety issue. That's what we're trying to solve. We're well on the path to solving that. We did a talk here at Summit this week with our lead consulting partner at Exida, which is they're a recognized international consulting expert for functional safety and a certification body. So they're very credible, and they presented on stage with us this week about how our approach is innovative, is new, and is trending to success.
That's very cool. Can you talk a little bit about the advantages that an open source operating system has from a modularity and declarative standpoint in meeting those certifications. So you want to go to certify something, really what we're looking for is what has changed, right? If something changed, then we need to prove that it then meets the requirements. It seems to me that Linux would be kind of unique, and open source software in general is kind of uniquely positioned to say we can choose the parts that we want to be fluid and change, and we can choose the parts that we want to keep the same for the purpose of certification and proving that this is a safety, proven system.
I think we want to use Linux as Linux is. Linux is evolving. It's evolving in communities, the kernel community and the different other communities that support Linux. And what we are doing to functional safety, we don't want to block innovation or freeze certain areas. We want to make Linux be Linux and meet the requirements of functional safety. We believe at Red Hat firmly that Linux and open source in general results in the highest quality software possible. That over time, with community-based review, the strict maintainer process that Linux goes through, the massive adoption of Linux based upon freedom and technical excellence over time leads to really an unbeatable quality solution. But that's been difficult to get by the functional safety process, which doesn't only look at quality metrics, but looks at how software is constructed. And that's been biased in favor of software in the small. Traditional safety critical software development follows, I'm going to use a term which I hope the audience will recognize, a traditional V model. In the upper left, starting with requirements, flowing to design, flowing to integration, and on the right side of the V, the validation and verification steps that lead to product release, and of course product maintenance. As very defined, separate steps. And that's not the way community software is done. And open source and communities have arisen in software for the last 30 or 40 years. Linux is over 25 years old, as we know, and it has resulted in a level of quality, a level of features, a level of functionality that really set the standard for our industry. But has been blocked from this functional safety, which has been a club that you have to be a software project in the small, proprietary, with vendor lock-in. All the things the industry wants to get rid of, frankly. But this functional safety equation has been tough to crack. That's why our approach to it with our Exeter partner, with innovation, is what we're seeking to do to unlock that problem.
Being that everything Red Hat does is open source, and I'm sure the in-vehicle stuff is no different, is it possible for me as just an ordinary individual to play with some of this stuff or get my hands on it?
What's interesting, Red Hat is an open development company, and we do work in the open. And we're constructing our Red Hat in-vehicle operating system product to release it, in the coming quarters. It's not released yet. And we've founded an automotive SIG we call CentOS Automotive SIG, very Red Hat-like name, but automotive specific, which is a community portal for participation in our project by anyone who wants to engage with us. No communication with Red Hat is required to engage with that site at all. No commercial relationship, no NDA, no nothing. And we do our nightly builds released on that site, that what we call the CentOS Automotive Stream Distribution. So if you're an automotive supplier, an SoC vendor, an OEM that builds cars and want to experiment with what Red Hat is doing, you can do that today. And you don't even need to communicate with Red Hat to do it. We welcome that communication. We want to help you. We want to understand what you're doing. But if you want to do things on your own for a while, you can do that.
That's awesome. I want to talk a little bit about the CI/CD pipeline challenges, right? So when you're building for a motherboard or a server or anything else, it's fairly well understood at this point. You're talking about a car. Man, there's so much complexity to something like that. What are some of the challenges with building a CI/CD pipeline for such a complex machine?
It's really a good question, and one on the minds of our OEM partners and the whole supply chain. If I'm constrained to having to have a piece of automotive hardware, or maybe multiple pieces of automotive hardware on my desk in order to do productive testing, we are not going to achieve the level of productivity that we need to realize, the vision of the software-defined vehicle. So we're going to have to leverage testing on other assets, right? And so we're really incorporating the notions of testing in the cloud, digital twins, virtualization, with our partners and with what Red Hat offers so that we can realize a productive work environment. And remember, automotive hardware is almost by definition in construction. It's not steady state hardware that I can buy off a shelf. Yeah. I'm buying, an early sample. Well, there's going to be a later sample that I've got to then incorporate. And so, okay, I've got the hardware on my desk is still not the answer. But if you have the hardware on your desk, it's going to change. So I have to have a development environment that accommodates that change. And if I can pair up with instances of my target hardware being emulated or virtualized in a cloud environment, and in not only an individual subsystem, but multiple subsystems, I'm going to it's a big leap forward in terms of productivity and development. And we're doing a couple of announcements here this week and demonstrations that illustrate that exact concept, both from Red Hat technology and with our partners.
What are some of the partners or industry, what are you most excited about the capabilities and benefits of moving to a software-defined vehicle and an in-vehicle operating system?
I'm most excited about bringing the power of open, and Red Hat embodies that, to developers, to OEMs, to realize what customers want. Customers want the latest features. They want the latest features. They want them now. They want the asset they buy to improve over time. The days of, I bought it, it's never going to get any better are well past us. We're accustomed now to the devices that we love. They get an update, and that update brings new features. Now, it may bring commercial opportunities. They may try to sell me something, but maybe that is something I'm looking for. Maybe that's something I'm willing to accept, that a commercial relationship, maybe a subscription is necessary. So those are the things that really get me excited. And interesting enough, that's what gets our OEMs excited, our automotive manufacturers. That's what gets the entire automotive supply chain excited, is to meet our customer requirements, is to do what the customers need. And open source is just a critical element in making that happen.
Can you talk a little bit about concerns with open source or some of the challenges that open source might have in this industry? For example, you look at John Deere and the approach that they take, trying to highly restrict customers. There's been other examples in the automotive industry as well of companies that try to take power away from their consumers. Do you see those as being challenges when you're trying to promote open source in the environment? Or do you look at it and say, no, you know what? Open source is going to functionally perform so much better that they're not going to have a choice, that they'll have to give that open access back to their customers?
Well, I'm at Red Hat. We're an open company, and I'm not about restricting choice to customers. Everything we're doing is open source. Everything we're doing is going to comply with those open source licenses. This is central to who we are and what our values are and what we bring. I don't really know what John Deere is doing that you're referring to. I think that in general, where there are safety critical systems, we have to be careful about managing, updating those systems. And that has to be a very controlled process. It has to comply with regulations. If it relies on functional safety argumentation, that argumentation has to bridge whatever modification I'm making. And I think that's something that we need to look at as an industry. Is freedom is what we're all about, but there's some freedoms that carry risk.
Aside from the partnership with, I believe it was GM that was announced last year, are there any other companies that have expressed interest in what you're doing?
Well, lots of excitement for what we're doing. So we have multiple announcements this week, multiple demonstrations this week with partners, not with auto manufacturers like GM, but stay tuned for news. Okay. We're working on an exciting set of proof of concepts with OEMs throughout the world, Asia, Europe, United States, or North America, and we're excited about the fact that we're engaging with the ecosystem. They're evaluating our technology, and we'll have more news for you soon.
Do you see any reason why hobbyists would not embrace what you're doing? So, for example, the newer vehicles are going to come out and they'll have software-defined vehicles in this operating system and all that. Do you see an avenue for tinkerers and hobbyists to go through and say, you know what, I'm going to see if I can retrofit this operating system or make this thing work or make this control system work on my older car or flash it onto a piece of hardware myself and see if I can? Is there an avenue for that, or is that too far outside of the realm of what's possible and what's really intended for what you're doing?
Look, I see that there is going to be a path for hobbyists.
Okay.
There's going to be some restrictions on what hobbyists can do. If you're taking control of potential safety critical systems, making modifications, there needs to be some process that tests that, that shows that you're not presenting a danger to others. Sure. For instance. But I think that the idea of an open source car is one I've been thinking about for a long time, that there could be somebody that builds a chassis and has reference implementations that are actually open and updatable. Now, that's going to carry some risk, and we're going to have to manage that risk. Now, I don't see traditional OEMs, the General Motors of the world, the Toyotas, doing this. It's going to be smaller companies and smaller interest groups, but I think that's going to come.
One thing we're asking everybody this year, what do you like best about open source, and what does open source mean to you personally?
Well, it's why I came to Red Hat. The values of a company are the thing that drive you, that make you excited. Of course, you have to find the right role in a company that has those values. So I found a great role. I come from an automotive background. I came into this job with great enthusiasm, knowing that the fundamental problem we were trying to solve, solving functional safety with Linux and open source, this really got me excited. So that's what I'm the most excited about. But the other thing that we mentioned earlier, bringing the reality, making software-defined vehicle a reality, having the car that you purchase improve over time, gets regular updates. The update process is smooth and meeting the expectation of the consumer without excessive waiting or retries or that one actually didn't work, let me roll that back. Let's minimize those blips. Let's meet customer expectations. Let's improve. Let's introduce features over time. Let's support our vehicles for a good long period of time. We don't want to say, now that we've adopted the software-defined vehicle concept, your car's only good for less than you want it. No, let's meet the customer demand for the life cycle of the vehicle. Those are the kind of things that make me excited.
Dan Noal, he is the Director of Product Management at Red Hat in-Vehicle OS and a guest this hour on the Ask Noah Show. Dan, thanks so much for taking the time to join us. We'll get you back in the program soon.
My pleasure. Look forward to it.
Chris Wright, he is the Chief Technology Officer at Red Hat and a guest this hour on the Ask Noah Show. Chris, welcome into the program.
Thank you.
Thanks for making the time. So, I think all around Red Hat Summit this year, the buzzword has been AI. Lots of AI, and what can we tie AI to? And I guess I want to dig a little bit below that. In years past, it's been things like the hybrid cloud, and everybody kind of seems to be scrambling in the industry, except for Red Hat. And Red Hat has this unique approach of, here's the application you want. Okay, here's how we'll deliver it to you. And it seems like they're keeping that approach consistent with AI. Oh, you want AI? Great. Here's how we take containers and leverage Linux, and we'll deliver that to you. Is that an accurate summation of Red Hat's approach to AI? And I guess maybe in a broader sense, the way that Red Hat serves its customers, the way that they deliver their customers' needs?
I would say so. I mean, there's a couple of core principles that underlie that. Certainly open source is one of those. Like everything we do starts in open source communities. Another piece that kind of goes along with that is flexibility and choice. So we're trying to enable that, and that's a big part of the hybrid cloud. When you think about delivering applications across the hybrid cloud, I think we understand that reasonably well. Cloud native principles, how do you build applications and then deploy them to the right location? We're seeing the same need for machine learning models. There's concerns around where you deploy inference and the associated data that comes with that, which might be really private data associated with an enterprise. But also, how do you do scale out training? So you might need a larger environment in a cloud to do the training process, and you might have a smaller footprint to do inference, and that looks very hybrid. So, and of course, we're leveraging these core technologies that we would call industry de facto standard technologies like Linux and Kubernetes to deliver applications as well as models. So yeah, I think you got it.
When you start working with your customers, do they find a unique advantage in Red Hat's ability to meet them in wherever they are? So for example, if you're Amazon or AWS, you're effectively tied to the internet because that's where your platform is. That's where you have to be. Red Hat's a bit different because it seems to me you're meeting customers where they're at. Can you talk a little bit about the way that your customers and your partners can leverage the ability to, hey, if it needs to be online, it's online. If it needs to be inside of a computer sitting inside of somebody's trunk, hey, that's where we'll put it. And Red Hat will meet your needs any which way you want them.
It's a little cliche to say, meet your customer where they are, but it really is what we try to do because we're thinking about flexibility and we're thinking about the choice that a customer needs to make as a business. Where's the best place to deploy this, to build this, to run this? And that is increasingly not just hybrid, but even extending out to edge environments, especially with AI workloads, where a pretty dominant workload on the edge is AI-based. And of course, you enter all the security concerns that we touched on briefly earlier. So our goal is to help build that flexibility and choice for a customer. And that is about meeting them where they are. And that could be physically. Is it in a data center? Is it in a public cloud? It could be connected or disconnected. These are all important considerations. It's also another kind of cliche way to put it. All of these things are a journey. And so some are further along on that path and some are just getting started. So there's also a meet them where they are from a tool set, capabilities, like where are you in the journey of modernizing applications or building and delivering machine learning models.
Do you see, or does Red Hat see AI as, another product offering that, hey, people are asking for it, we can deliver that, we're technically competent, we'll do that? Or do you see that as kind of the start of something more? Do you see that being the foundation of something bigger down the road?
It's always hard to predict the future, right? But we see this as a pretty big investment in a future view of what an enterprise looks like. So much of the work to date has gone into building and deploying applications. You think of an enterprise as a technology company or a software company. So you're building applications to define your business, to differentiate your business. The future looks like those applications are still important. And we're bringing in this new workload, machine learning workload, AI workloads, generative AI. Where does it impact the enterprise? Having commonality from an operational point of view with Linux and Kubernetes or RHEL and OpenShift, having the discipline and rigor of understanding the lifecycle management of not just applications, but also models. This is the future of the enterprise, and it's not just applications. So it isn't just add a new workload. It's a whole new workflow, new process, and you got to think about this at scale. So I'd say the future of the enterprise looks quite different, and we're kind of investing to meet those needs as they grow into, today it's nascent. In the future, it's the enterprise is half apps and half models.
Do you think open source provides unique advantage in that space, or do you think that it's somewhat of a challenge to be overcome insofar as everybody's trying to compete, everybody's trying to have their edge? Do you think when it comes to things like AI and machine learning that open source provides an advantage, or is it a bit of a challenge?
It's early days in that conversation. It's a really fascinating conversation. I like this one. Open source in general is tried and true. It is a proven way to develop and deliver really important technology across the industry. Again, Linux, Kubernetes, these are like de facto standards. When we get into machine learning and AI models, the frameworks and the tools tend to be open source based. The models themselves, we're still trying to figure out exactly what that means. So I think there's something really powerful in collaborative development. And I think it's proven through the open source development model. And then there's a different question of what are the business models connected to that collaborative development? And you see a whole proliferation of those models, and some work really well, some struggle, and some even work well at a point in time. And then, over time, the world evolves. So we're going to see that same thing play out in the machine learning space and generative AI. If it were me, I'm going to be betting on the open side. I think open source is really the power that brings so much creativity and forms the future view of how we do IT. I think of it as the innovation engine for the industry. Historically, more application focused. In the future, it's just as much application as it is models from that open source innovation point of view. So I think that's where I'm placing my bets.
Models aside, do you think that there is an inherent advantage from the standpoint that, if you have even if it's a very good model, if it's proprietary, it's in one very limited place. If it's open source, even if on the onset, it's maybe a slightly inferior model. The fact that it can become more prolific, the fact that more people can use it and leverage it and gain industry insight into it and experience with it, in the end, that makes it a winner.
I think there's that aspect, which I would agree with. I would also add, think of the flywheel effect of as you create more groundswell of interest around a particular technology, it outpaces everything else. So right now what we see is very frequently, it feels like daily, but it's not quite. You see the next model coming out, and their models are measured in terms of number of parameters and the performance of the model and the accuracy of the model. Yeah. Each subsequent model is better, effectively. Something that's on par, because one day this one's the best, the next day this other one's the best. So something that's in the mix, it's on par, and has community traction. You can see how it would quickly outpace any individual company's ability to do the innovation by themselves. So I don't think we're there yet. I think we're at the beginning of this shift, which is why it's so exciting. But in the end, I think that community collaborative model just outpaces anything else.
You personally, are you more interested in the up and coming new, very, early days of technology, or are you more of a fan of the more established thing? What makes you more comfortable? What makes you more excited?
That's an easy one. I'm a technologist. My role, CTO for Red Hat, I focus a lot on the future technologies. Now, one of the things that's interesting in that context is people often ask me, like, what do you see 3 to 5 years? What's going to be new? Like, well, that's pretty hard to predict. What will be new that we haven't heard about today in 3 to 5 years? But you also have to put into context the things that we're doing today that are new and emergent. It takes 3 to 5 years for those things to establish themselves as the norm within enterprise businesses. So in that context, I like not only what's new, but also how do you make it accessible and how do you make it ultimately more the norm or ubiquitous across the enterprise. So if you're always chasing the newest, you risk never getting anything done. So there's a balance in there of like, we've got to pay attention to cool new stuff, but we also have to make it useful for people.
Yes, and profitable for the companies. So talking about AI, there's a bit of discussion around what open source means in regard to AI. And you kind of touched on this with, the difference between the models and some of the frameworks and stuff. So some consider, local free use for personal or commercial means that's open source. Other people would say it's free as long as you have access to the model. And others yet say, like the Open Source Initiative have said, well, it's not open source unless the model, weights, and training data sets are all available. Where does Red Hat fall down in that discussion?
Well, we're going to take the stance of the more open, the more better. So we're always going to stretch forward to be more open. I would go a little further and say, if you have access to an API, like open access to an API, that's not open source. That's just open access to technology. Sure. So that first category, I'd say it's just disingenuous to call it open source. There's a gray zone in the middle where is it the license of the model? Is it the model plus weights? Is it the model plus weights plus pre-training data? And there we can have robust conversations, and we're going to always lean towards them more open. And of course, it's a whole world and community, and we can't do it by ourselves. So we got to make sure we're pulling a community along together with us. But you see today, the state of the art includes all of the above: open source licenses for models, visibility into the weights, at least descriptions of training data. Sometimes the training data sets themselves have licenses that aren't redistributable, so it gets a little bit complicated just where we are today. And then the actual process of doing the pre-training of a foundation model can be quite complicated and very expensive because you use huge scale-out infrastructure for extended periods of time. So unlike source code and a compiler or a non-compiled language, just a runtime, which you can cheaply experience on your laptop, doing pre-training might cost tens or even hundreds of millions of dollars. So it's just a different dynamic when, like, how does a community come up with those funds? It doesn't it doesn't translate quite as well. So that's part of why we're still learning what it means to have open source in this context.
What are the impacts of generative AI or AI in general to software development? Is it just a function of fixing code? Do you see a time where it generates all the codes and just solves a problem? What do you think the impact is?
It's a pretty exciting area, and I think it will continue to evolve. So clearly there's a variety of different assistants, code assistants that are out there, some open source, some commercial, and those are mostly focused on helping you write code. But there's code development, there's documentation around code, there's unit test development for the code that you're writing, there's sort of analysis of code bases to either understand where there may be things like security vulnerabilities or better ways to do, whether it's refactoring or better ways to do what you're trying to achieve in code. So there's a lot of different aspects of how we can improve the development process. Some are more effective than others, and then there's resistance from developers. Like I'm really good at this task, and I don't think an AI model is going to be better than I am. I don't necessarily think of it that way. It's more like you only have two hands and you can only type so fast. So how much work can you get done? And I know you and I have the exact same skills and we're given the same task, and you're given a robust rough draft and I'm given a blank sheet of paper. You're going to finish a lot faster and probably with a higher quality output. So I don't see it quite as threatening, but how do we make it work? And then there's some work in the academic space around agents and using agents to hand off tasks from one agent to the other to build feedback loops in, using generative AI, but not being restricted to just generating code. They call it zero-shot generation. That's really interesting. And you're starting to see some feedback loops that can produce some code, compile it, test it, just debug it, discover it's broken, fix it. There's even some commercial products in this case, in this space. There's a lot of interest in that whole agent-based machine learning future. And I think that shows a lot of promise, which probably shines a light on there's just more than meets the eye. It's not just generating code. It's just a whole big set of opportunities in there. I
want to be clear. I'm not asking you to give any Red Hat secrets away, but are you aware of any efforts or any projects working towards deeper AI integration from Red Hat's perspective?
We have a sort of a multi-pronged approach to AI across our portfolio. On the one hand, we think of it as mostly what we've talked about. It's a workload that runs on our platform, whether that's the inference, the training, the iterative process of tuning and improving a model. In a sense. There's another aspect, which is where can we leverage those same tools and infuse it into our products? And we started that last year with Ansible Lightspeed, which is a generative AI tool to generate playbooks for Ansible. We're extending that work across our portfolio. So we'll have the abilities in OpenShift to do something that we would just call OpenShift Lightspeed. So it's the same idea, like how can you be more productive with that platform? Same for RHEL. So whether it's, think of it this way, we have a ton of experience as engineers and knowledge bases around the operations of our platform. So we want to take that experience, infuse that into a generative AI tool that can help users of our platforms be more productive. So I think that's just an important part of, it's a workload that runs on our platform, but it's also infused into our platform.
Chris Wright, he is the Chief Technology Officer for Red Hat and a guest this hour on the Ask Noah Show. Chris, I appreciate the time. As always, we'll get you back in the program soon.
Awesome. Thank you.
The music in my ears means we're out of time. I thank you for joining us. We record this show live every Tuesday at 6 p.m. Central. You could join us by going to AskNoahShow.com. Did you miss it? That's fine. You can catch the backlog at podcast.AskNoahShow.com. There you'll find not only all of the articles and references I used to put all the show together, but you can find the back catalog. Start at episode 1, work your way up. If you want to keep up to date on the latest, join us on X. I'm at Colonel Linux. He's at Linux Ovens. The show at Ask Noah Show. We're back next Tuesday at 6 p.m. Central. AskNoahShow.com. Have a good week.